Let's talk about IPLs, because it's more than just flashing up a Welcome to ZOS splash screen and then suddenly you're ready to run enterprise workloads. An initial program load is technically the act of loading a copy of the operating system, typically from DASD, into the processor's main storage area and running it or executing it. That disk that you point an LPAR to for it to IPL off of has what's called a bootstrap module at cylinder 0, track 0. What that means is it's literally the first bit of data the OS sees when it reads off of it. The bootstrap module is loaded into real memory at address 0. That's the first available memory slot that the LPAR has access to, and then control is passed to it. The bootstrap isn't the main operating system. It's just enough to assemble the pieces and information needed to bring up the full operating system. So the bootstrap reads the IPL control program, that's the IEA IPL00, also known as the IPL text, and passes control to that. More on that in a bit. This, in turn, starts the more complex tasks of loading the full operating system and bringing that up. On its way up, the OS looks for what's called a load parameter, which consists of 8 characters. And this is a nice and compact way of telling the LPAR how we want it to IPL. The first 4 characters are the device number of the IODF device. That's what contains all of the hardware and software configuration for the system. Characters 5 and 6 contain the load member. More on that in a bit as well. The 7th position indicates what messages and prompts should be displayed at IPL time. And then the last position, way at the end, is the IEA NUC 0 member, usually pronounced IEA Nuke 0. Guess what? More on that in a bit too. During IPL, the system will begin looking for the information it needs to fully come up. First thing it'll look for is the load XX member. This tells it some vital information about the system. So the IPL Resource Initialization Module, IRIM, first attempts to locate the loadxx member in the sys0.iplparm dataset. This is just a dataset where the loadxx member is kept. It's actually not labeled as loadxx. That's just the common way of saying it could be load 00 or load 01 or whatever we told it to look for in characters 5 and 6 of the load parameter. If it's not there, it'll look in sys1.iplparm, and then in sys2.iplparm, and all the way up to sys9.iplparm. If it cannot find the loadxx member, the system will enter a non-restartable wait state. The IPL was not successful, and trying it again won't help until we fix something. If the sys.whatever IPLparm couldn't be found on the IODF volume, the search continues, and it will check in the sys1.parmlib dataset of the IODF volume. By the way, a volume is just a logical DASD disk. You can imagine it like a disk drive here. Anyway, if it can't find it there, it'll look in sys1.parmlib on another volume called the sysres volume. And if it can't find it there, then we're done. The IPL was unsuccessful. For a full breakdown of that search process at IPL time, there is a great document included in the notes for this lesson. But the short version of this is that the IPLing system needs to find its loadxx member. And once it finds it, it'll be opened, and then it will have all the information it needs, including the nucleus suffix, the master catalog name, and the suffix of the IEA sysxx members. Now, we mentioned a couple of things in there without going into full detail. Once you get a hands-on system and you start looking at those members and checking out those screens, you'll get a better picture for what type of data is in them and how they all fit together. These are all just a couple of ways that systems can start up. And as you can see, it's important that all the pieces be set up and in the right place when we want to bring up or IPL an LPAR.